So now Unicode transformation format. This is a fantastic thing, guys. Trust me. Such a fantastic encoding this is. This is a miraculous thing that was happened in somewhere in 2000s, and this was fantastic representation is what I feel, because very powerful encoding. Very powerful encoding. Okay, now imagine I have a text message like this, which is HA ha space poop symbol. That's an emoji, correct? So the poop is an emoji symbol, and I basically want to convert or represent this in the binary in my computer's memory. So how can I do that? That's the question, correct? So if you look at the equivalent decimal number for each of this character from the Unicode table, you could see H is represented as 72, A is represented as 97, space is also a symbol, correct? That's correct. That's correct. So this is the symbol, and the equivalent decimal number for each symbol from the Unicode table is this. So H is 72, A is 97. So these were basically the ASCII characters, correct? Even the space is also ASCII character. Any letter that is less than 127 is an ASCII character. The first 127 symbols of your Unicode are ASCII. They still remains the same, and their numbers remains the same. So the space is still given with 32. If you go to ASCII sheet, you will still see the space as 32. And comes to A, it's 97, and one comes to H, it's going to be 72. Okay, go and look at the ASCII mappings. You will still see the same numbers for H, A, and space. When it comes to the poop symbol is something not from the ASCII encoding, correct? It doesn't have any ASCII number. So, but if you, but it's a Unicode character. That means, sorry, it's not. It's a Unicode symbol. So the Unicode, the equivalent number for the this poop symbol in your Unicode is this number. It's 128169. Are you guys following what I'm saying? So the ASCII doesn't have this poop symbol thing, right? The poop emoji. So, but if you take the Unicode, the decimal number for this particular poop symbol is 128169. Are you guys following me? In the same way, if you take any character, any letter from Telugu or Urdu or Hindi, they have the equivalent decimal numbers. Are you guys getting me? So in the way how the ASCII has the symbol to the decimal number mapping, in the same way Unicode also has, Unicode table or the Unicode sheet also has the symbol to decimal number mapping, and also that can be represented in hexadecimal number. Are you guys following what I'm saying? So the equivalent number of this poop symbol, the equivalent decimal number of the poop symbol in the Unicode table is 128169, as simple as it is. Okay. So now, how do we store this in binary? That's the question, correct? Ultimately, what computers understand is a binary. We have been keep talking about this. So how can we represent this in the binary? So a Unicode code point is a numerical number. So what is the code point? Code point is nothing but the numbers that you're seeing over here. When you talk in the context of Unicode, we call them as code point, as simple as it is. The numbers that you're seeing over here, when we talk in the context of Unicodes, we call this as the code points, and typically expressed in hexadecimal numbers. So usually we are more familiar with the decimal number system, but you can still represent the same thing in the hexadecimal number system also. So if you represent the 72 in the hexadecimal, this is how it looks like. U plus says what? U plus means Unicode. We discussed about this, correct? Whenever you see U plus, then the number, hexadecimal number, that means it's a Unicode number, as simple as it is. Okay, and A, which is 97 in decimal, can be represented as U plus 0061 in hexadecimal. When you say U plus, that's an Unicode, as simple as it is. In the same way, per poop emoji, this is how it can be represented in the hexadecimal number. Now we have seen the equivalent decimal numbers and hexadecimal numbers, and this are called as a code points. You just need to remember these jargons because these jargons are very important. So when you talk in a context of Unicode, the decimal number or a hexadecimal number, the equivalent decimal number and hexadecimal number of a symbol is called code point, as simple as it is. Don't confuse. Code point is very simple. It's just a number that you give to, it could be an hexadecimal number or it could be a decimal number that is being given for a symbol in the Unicode table, as simple as it is. Okay. Now, that uniquely identifies a character or a symbol in the Unicode standard, as simple as it is. And each character in the Unicode standard is assigned a Unicode code point. Unicode code point is nothing but a number, okay, and which serves the identifier to the characters. So they are like an identifiers, correct? Because ultimately your symbols has to be mapped with either a decimal or a Unicode, the hexadecimal, that can be easily converted into a binary. We looked at both the ways, correct? How to convert a binary into decimal, decimal into binary, and hexadecimal also into binary. Am I right or wrong? So that's the reason your symbols are being mapped with either binary or the hexadecimal, as simple as it is. But when you consider Unicodes, usually you should prefer to always consider hexadecimal number representations because your decimal numbers are too big. Am I right or wrong? We looked at it. So if you look at it, this is the maximum number that you can think of a Unicode thing, correct? This is too big to say. But when you convert this into a hexa, this will not be that big. So that's the reason usually the decimals are represented in Unicode in hexa. When we talk in the Unicode context. Are you guys following what I'm saying?